In the last video, we looked at unit cells and crystal lattices and kind of gave it a background, but now let's use that information to talk about structures of metallic solids. And in this course, all we're going to be doing is looking at cubic unit cells. And in a cubic unit cell, all sides are going to be equal, and all angles are 90 degrees. So there are three main types of cubic unit cells that we're going to look at. They're primitive, body-centered, and face-centered. And each of these structures are based on the placement of atoms within the unit cell. So over here on the left, I've shown three identical boxes. And each of these unit cells and each of the bricks are going to be cubes that can repeat in three dimensions. Okay, so the primitive, or sometimes referred to as the simple cubic structure, has lattice points only on corners. And each corner is shared by 8 different cells. So if I was going to put the atoms on this cubic or primitive or simple cubic cell, I need to put 8 atoms on each of the corners of this particular unit cell. So I would get something that looks like this. One of the things that we need to look at as we investigate these various cells is we need to look at the empirical formula of a particular solid. And the empirical formula of a solid is based on the number of atoms inside the unit cell. Okay, so we can look at these particular unit cells. So for example, if I was looking down the top of this axis and we have 4 unit cells next to each other and there's an atom sitting on here, okay, if we're looking at this particular unit cell right here, we are only looking at this portion of the atom because that is inside this particular unit cell. Okay, so the empirical formula is based on the number of atoms inside the unit cell, and we typically see fractions of those atoms in the unit cell. Okay, so if we're on a center, the fraction of the atom contained in the unit cell is going to be 1 because it's inside this particular cube. Okay, if we're on a face, only half of that atom is contained inside the unit cell. If we're on an edge, only 1/4 of the atom is in the unit cell. And if we're on a corner, 1/8 of that atom is going to be inside the unit cell. So if we go back to our primitive cubic cell here, we have 8 atoms, and all 8 of those atoms are on a corner. So this atom down here is going to be shared by 8 different unit cells. So only 1/8 of the atom, since it's on a corner, is going to be in the unit cell. So if we do 8 times 1/8, there's going to be 1 atom per unit cell. Okay, so that's our primitive cubic. if we looked at a body-centered cubic, a body-centered cubic is nearly identical to a primitive cubic cell, with one exception. So on the body center, we have lattice points on 8 corners and in the center. So we'll put our atoms on the 8 corners here. And then, in addition, we need to put another atom directly in the center of this cube. So I'll put one right in here, which is going to be directly in the center of that cube. So just like the primitive cubic, we have 8 atoms times 1/8 of an atom from the corners. And then we have 1 atom times 1 from the center. So this gives the 8 on the corners gives 1 atom in the unit cell. And then the one in the center also gives 1 atom in the unit cell. So these two combined gives 2 atoms per unit cell if we have a body-centered cubic. Now if we move on to the face-centered cubic, we have lattice points on the faces and the corners. So just like the simple cubic, we have 1, 2, 3, 4, 5, 6, 7, 8 atoms on all the corners. So we have 8 atoms times 1/8 of an atom on the corner gives us 1 atom in the unit cell. Now we have to look at all of our atoms on the faces. And I'm going to use a different color here to represent each of these atoms. So on the faces, we have 1 atom on the top face and another atom on the bottom face. We have 1 atom over here on the left face, another atom on the right face, and then we have 1 atom on the front face and 1 atom on the back face. Okay, so we have 6 atoms times, if we look at the face centering occupancy, we get 1/2 of an atom for a face, which gives us 3 atoms in the unit cell from the face-centered atoms. So if we add these together, in a face-centered cubic, we're going to get 4 atoms per unit cell. And this is going to be the foundation and the basis for each of these structures in metallic solids, which will allow us to calculate something like density, which we'll do an example of in the next video.